Hi, in this video I'm going to discuss a question direct from IIT JAM 2016 biotechnology paper. So this question is for on NMR. Now they gave a structure and they labeled all the hydrogen by A, B and C. Now they ask uh, which of the options are correct. So this is a MSQ question, that means multiple option could be correct, more than one option could be correct. Now we have to say which options could be correct. Now we would analyze every option and we would construct the NMR spectrum for this molecule and we would see which option is correct. To build a NMR spectra, we first need to identify the different hydrogen atoms and their environments. When we understand the environments of the hydrogen ion, then we can build a H1 NMR spectra. So the H1 NMR spectra of this molecule would particularly look like somewhat. So here we have these x-axis, and in y-axis you would put ppm and here you would put abundance. But forget about ppm. Let's say we just for understanding purpose we are plotting energy in the x-axis. So you would have a reference peak over here very near to 0 and that you would call TMS peak, and other peaks you would have a peak over here, then you would have a peak somewhere here. So what do you mean by downfield and upfield? So here written downfield and upfield, so you have to understand about a downfield and upfield peak. So these three peaks are the NMR spectrum for this molecule. Now if we label the hydrogen molecule, so this peak that you can see over here, this is for the hydrogens of A, this is for hydrogens of the B, and this is for hydrogen of the C. So any peak that is quite far away from 0, which possesses high energy, would be termed as downfield. So this peak is downfield peak, I mean most downfield peak with respect to B. So with respect to B, A is downfield. Again with respect to C, B is downfield. So let's analyze the first option. First option says A is reasonable upfield to proton C. So they said that A is upfield than this C, and from this spectra you can see A is actually downfield. A is downfield in the spectra. So this option could not be correct. So this option is wrong. So how would you know that a peak is downfield or upfield? A peak would have high energy or low energy. The trick is just see the molecular environment. Here the carbon is attached to bromine, and as it is a highly electronegative substance, bromine would pull the electron density towards itself. So here around carbon there is a de-shielded environment, very important. So de-shielded environment. So when there is a de-shielded environment around any atom, so the peak corresponding to it would be downfield peak. That is why we get most downfield peak for A. Then if we talk about B, the electron density is shifted towards the left but not as much as A. So that is why for this particular B hydrogens we have a peak a little bit upfield to A, and it has a little bit less energy than A, and the least energy is in C because these electrons are not that much pulled towards left. So it is less de-shielded, it is shielded environment. This environment is shielded and here the environment is de-shielded. This environment is de-shielded. If you don't know what is shielding and de-shielding, you should watch my other videos in the biophysics section. However, the trick is you have to look about de-shielded and shielded environment. If the environment is shielded, a thumb rule is the peak would be upfilled. A peak would be very close to zero. And see, this is a shielded environment and the peak is very close to zero. And this peak is de-shielded and this peak is far away from zero. And far away from zero. That is why the first option is incorrect. And let's see the second option. Protons of B resonate downfield to protons of C. So B is downfield to C. And as from the spectrum, you can see B is really downfield to C because B is more de-shielded than C. So B should be downfield and C should be upfield. So this option is correct. Let's see whether other options are correct or incorrect. There are two triplets and one quadruplet of the spectrum. Now this is very hard. Triplet and quadruplet, what are these? These are actually fine splitting of these peaks. So these triplet, quadruplet, everything is fine splitting of these peaks. We would analyze this option later. Now let's come to D. Proton A appears as a triplet with high chemical shift and comparison to proton in C. So we have to understand splitting or JJ coupling. So this is a very hard concept, but for cracking this MCQ, you can take a very easy example, a very easy rule, how you can solve this. So whatever you have to do is for A peak, to understand how A peak could get finely splitted into other peaks, you just look at its neighbor hydrogen. So how many hydrogen are there neighbor to A? So the A's neighbor hydrogen are B hydrogens. So there are two B hydrogens and the rule is called N+1 rule. So now if we want to know the fine splitting of A, we would use N+1 rule. So which hydrogen is neighbor to A? These hydrogens. So there are two hydrogen, so N is equal to 2 and 1. So there is a 3, it's actually splitted in 3 peaks. So this A peak, if we zoom this A peak, actually we would see somewhat it is splitted in 3 peaks like these. So this is called triplet. Now let's analyze the C peak. So the nearest hydrogen to C is also B is a hydrogen. There are 2 hydrogen. So for if we analyze for C, it is N+1 rule, and here is 2 hydrogen near to C, that means the B hydrogens, and 1. So the total splitting is 3 again. That means this C peak is also splitted into 3 small peaks. So it is actually splitted in 3 small peaks if we analyze it closer. And B is also splitted in small peaks due to coupling, spin-spin interaction. But the problem is with B, you can't use the N+1 rule. The N+1 rule is not valid for B, as for B we have its neighbors on both sides. So C hydrogens are neighbor of B and A hydrogens are neighbor of B. So you can't use this type of N+1 rule. But what you can say that when this kind of scenario occurs, you have multiple peak. Multiple peak means more than 6, I think. So here you have, there are 2 triplet, yeah, it's right, and 1 quadruplet spectrum. No, it's not quadruplet. Another would be actually multiple peak. So it's not quadruplet. Yes, there are 2 triplet peaks. Peak of A and peak of C are actually splitted into 3 fine peaks. So this is correct, but this quadruplet, this is not correct. So that is why this whole option is incorrect. Now let's come to the 4th option. Proton A appear as a triplet with high chemical shift. Okay, here is another new term, chemical shift. We would in a moment see what is chemical shift. In comparison to proton C, proton A appears as triplet with high chemical shift in comparison to proton C. So as you can see from the spectrum, proton C and proton A, protons of A and protons of C, if we analyze their spectrum, both have triplet splitting. So this is correct. The triplet splitting is correct. Now chemical shift. Chemical shift means the peak of a particular thing is how much shifted from the zero, how much far away from the zero. In easy word, they are just asking how much downfield the peak is. So they said proton of A appears as triplet and high chemical shift in comparison to proton C. So the how much far away the proton C is here from zero, this much, and how much away proton A is from zero, this much. So proton A has higher chemical shift. So chemical shift for proton A is higher, and both proton peaks corresponding to proton A and proton C will split into triplet due to spin-spin interaction. That is why this option is correct. So after analyzing the question, this question was pretty hard, and the correct answer is B and the correct answer is D. So these two answers are correct. I hope you understand why they are correct. Many things I've skipped, and I try to understand it in a bit unscientific manner, but these are just tricks how you can crack this type of hard MCQs in a moment. Hope that helped you. Please like and subscribe for more videos.